In this video, I'm going to run through setting up a radio tower model. I've already imported the geometry. It consists of a solid base plate, some gusset plates that are welded to vertical tubes, and then a solid circular bar cross member that goes to each of the tubes. So I'm going to mesh what you see here with different techniques, and then what I'm going to do is copy the mesh in the positive Z direction to get the length that I need. So the first thing I'm going to do is use the meshing toolbox to add washers on the holes of the base plate where the anchor bolts will be. And what I'm going to do is align the splits of the washers tangentially to the curves on the outside of the solid here. And this is going to help when I mesh later. I'll get a little better mesh quality, and also I can constrain around the holes more similar to what you would see in the real world environment. So as I finish up adding the washers here, what you'll notice is that I turned on the split solid in the meshing toolbox, and that'll project the splits all the way through the depth of the solid. So I'm going to go ahead and put a mesh size on the solid base plate. And what I'm going to do is select all the splits of the solid washers as well. And that way, when I'm sizing this, the adjacent surfaces will be the same map, and I won't have to do a coincident node check later. The mesh will just be connected. So I want the base plate to be a hex mesh, so I'm going to check hex meshing and set the size to 0.5 and also 2 elements through the thickness. Now I can go ahead and hex mesh my solid. I'm going to select previous, and that way I don't have to reselect all the splits of the solids. I selected steel for the material of the base plate, and I'm also going to use this for the gussets, the tubes, and the cross members for this example here. So I've meshed my base plate here, and I'm pretty content. The quality of the mesh looks pretty good, so I'm going to move on to the gusset plates. I'm going to use the mid-surface automatic command, and in the entity selection dialog, I can use the on-solid method, and that way I can just select the one solid and it'll grab all the surfaces that are attached to it. I'm going to check on the combined tangent surfaces, and that's going to stitch all the surfaces that are created from this mid-surface. And then I'm going to use the measuring tool, and that'll automatically propagate the target thickness. One thing I like to do is use the draw erase tool, and this gives me the ability to hide or show selected entities. So I erased the solid plate there, and now I'm left with my mid-surface. And you'll actually notice that when I did the mid-surface automatic command, it generates these mid-surfaces into a group. So then I can actually use that. So let's say when I want to size my mesh now, I can use from group and add those surfaces very quickly without having to go in and select all the different surfaces. So I'm going to size this to 0.2. And now I'm actually going to mesh the surfaces. I can just click previous now, and I'm going to create my property. If you remember from the mid surface command, I used the measuring tool to get 0.15 of the solid. So I'm re-entering that to create my plate property. Overall, the mesh looks pretty good, but I do see a couple of elements that look like their quality isn't that great. So I'm going to use the meshing toolbox with feature removal and remove a couple of these miscellaneous points. I'm going to remove the 2 extra points on the top curve here, and that's actually going to create an uneven mesh size between the top and bottom curve. So I'm going to use the mesh sizing to decrease the size on the bottom curve, and that way I get a more mapped mesh on that surface for a better mesh quality. So I meshed my base with solid elements and my gusset plate with shell elements, and now I'm going to create a glued contact property to mimic them being welded together. When I create my contact property, I'm going to click the linear tab and set the contact type to glued and just use the defaults. So I'm going to create my first connection region, and I'm going to title this one to base plate. And I can use the surfaces to go and grab the top surface of the base plate. So with auto repeat on, now I can create the connection region for the gusset plate. And what I'm going to do now is use elements. I'll title this gusset plate, and I'm going to hit add multiple. So I'm going to select one of the edges at the bottom of the gusset plate, and you'll see that with the tolerance set to 20, it doesn't grab all those. So I'm going to bump it up to 40, and now you'll see that it grabs the whole edge. And now that I have both regions created, all I have to do is create my connector. I'm going to select the property that I made, and the base plate as the master, and the gusset plate as the slave. So the next step I'm going to do is prepping to mesh the vertical tubes and the cross members, and I'm actually going to mesh both of these with beam elements. So because I'm starting from solids here, I'm going to use the curve centerline command, and what that's going to do is allow me to select solids, and it's automatically going to create a center line and associate a material and create the corresponding property with the cross section from each solid that I selected. So I can hide the solids, and you'll see that there's a center line created, and then I can expand the model info tree to show the properties that have been created. So I'm going to go ahead and mesh the vertical tube, and I'm going to start out by sizing it. I'm going to use an element size of 0.625, and then when I mesh this, I can use the meshing attributes that's associated with it from when I use the curve centerline command. So I'm going to turn on element thicknesses and just get a good visualization of what's going on here. So you can see, you know, in the real case, it would be welded along the seams here, the tube to the gusset plate. So I'm going to turn off thicknesses again, and what I'm going to do is basically connect this using some rigid elements. So I'm going to use mesh connect closest link. So in the selection dialog, to select nodes to generate from, I'm going to use the on curves method and select the curves that'll model the seam of where it's going to be welded to the tube. And in the generate to, I'm just going to select a couple of the nodes along the vertical tube in the area of where the weld would be. And so I'm going to change this to the rigid element as the connection type and select all degrees of freedom. And I'm also going to reverse the direction, and this is because I want the dependent node to be on the gusset plate. So you can see now that my vertical tube is connected to the gusset plate. Again, it's just kind of modeling the weld here. So you'll notice that I only meshed one of the gusset plates and one of the vertical tubes. And that's because I'm going to do a rotation copy, and that's going to save me some time on repeating some of the steps I've already done, like meshing the surfaces and the curves, and also connecting the two with rigid elements. So I'm going to use mesh rotate element, and in the entity selection, I'm going to use the method on surface to select my mid surfaces in that group. Then I'm going to switch over to on curve and grab my vertical tube, and then switch over to ID and use the pick method to add connected elements, and that's going to grab my rigid elements that I had created for the connection. So now that I can see I had all the elements selected that I needed, I can follow through with the rotation command. And I'm going to make sure I have geometry and connections and regions turned on and other entities to include. And then in repetitions, I'm going to change that to 2. So now when I'm prompted to select my rotation axis, I'm going to use a little trick here. I'm going to hit Control Z, and that's going to bring up a selection to pick a point, and I'm going to use the center of gravity of surface method to select the top surface, and then repeat that to select the bottom surface, and that way I have a rotation axis in the center of the base plate, and I can change my rotation angle to 120. So I'm just going to erase the other two gusset plates, and you'll see that with the rotation copy I did, I'm left with both the surfaces and the mesh. So because I chose to include connection regions when I did the rotate copy, the two copied gusset plates actually already have connection regions on the edges. So now I just need to go and create the other two connectors between the gusset plate edges and the base plate. So I'm going to go ahead and create those two real quick. And then using my model info tree, I'm going to go in here and highlight the connectors just to visualize that they're all there. And now I can move on to my next step. I'm going to create a new group here, and what I'm going to do is I'm going to group the curves of the cross member center line, and that way when I go to mesh size this and mesh it, and also another rotation copy, I can easily select these. I don't have to select all the curves over and over again. So I'm going to go ahead and put a mesh size on the curves that make up the cross member. Again, these are the center lines. So I'm going to use my group to add those curves. And I'm going to use an element size of 1. And then I'm also going to do minimum elements on a line to be 4. And that way on some of the curves or the bends there, I get a couple more elements than what I would have if I just selected 1. And that way it follows the shape more. So now I can mesh these, and again, I can just use the meshing attributes that are associated with the curves from the curve center line command. And then one last thing I'm going to do is actually use the meshing toolbox to size down the end pieces of the cross member again. I set the minimum elements on a line to be 4, and I really want it only on the bends, not the smaller lines that make up the end pieces of the cross member. So I'm just going to set those to 1. So now that I have the cross member mesh, I'm going to go ahead and turn on thicknesses and cross section just to visualize, where the cross member and the vertical tubes are lining up. And again, there would be a weld there. So I'm going to repeat my steps with the mesh connect closest link. And again, I'm going to select a couple nodes on the bend of the cross member. And the generate to, I'm going to select a node on the vertical tube and use the rigid elements, select all degrees of freedom. And again, reverse direction. So I'm going to go ahead and continue on and actually repeat that step with the 3 other bends on the cross member. So I'll skip ahead a little bit. And as you see now, I have it all connected to the vertical tubes, my cross member here. And now I can actually do another rotate copy for this. So I'm going to go ahead and use mesh, rotate element again. And then in the entity selection dialog, I'm going to use the on curve method and select my cross members group that I previously created. I'm going to highlight those, and you can see it grabs the elements on the cross members. Now I'm going to switch over to ID so I can use the pick and add connected elements. And that way it grabs the rigid elements that are connected to the vertical tubes as well. So again, I'm going to switch my repetitions to 2. And now I'm going to use my trick again, where I'm selecting the axis of rotation using Control Z. So I can select the CG of surface and select the top surface and the bottom surface of the base plate again, and change my rotation angle to 120. And I'm going to go ahead and hide my solids from the other 2 cross members. And I can see at this point, I pretty much have my mesh set up. I'm going to turn off the mesh sizing on the curves here just for visualization purposes. And earlier in the video, I mentioned that I'd be copying the mesh in the positive Z direction just to get the height that I wanted. So I'm going to use mesh copy element. And the first thing I'm going to select is using on curves and select my cross members. And then switch over to ID. And again, I'm going to use the add connected elements. And that way I grab the rigid elements connecting to the vertical tubes. And I'm going to switch back over to on curves and get my vertical tubes. And I did it in this order, so that way when I did the add connected elements, I wouldn't get the rigids that were connecting the gusset plates to the vertical tubes. And I'm going to copy this up 19 times. I'm just going to use a long vector. And I'm going to select the base of the vertical tube and go up to the top of the vertical tube, and that way my mesh will align. So I've done my copy and I've got my tower to the length I need it to be. So when I did my vertical copy of my mesh and even the rotation copy of the cross members, I'm going to have some overlapping nodes, and I want to merge those so everything's connected. So what I'm going to do is actually hide the base plate solid and with it the elements, and that way when I do my tools check coincident nodes, in the node selection dialog, I can actually do a select visible, and that way I'm not going to merge any nodes that may have been coincident between the gusset plate and the base plate. And so you probably noticed a couple rigid elements connected from the cross members to the vertical tubes, and also the vertical tubes that were copied straight up had some coincident nodes. And so I just went back into my array selection, and I'm actually removing solid ID 4, which is my base plate, so I can see that again. So the last thing I'm going to do here is create a rigid connection between the vertical tube and the hole of the base plate where the tube would slot into, kind of mimicking a weld between those two. So I'm just going to go ahead and create a rigid element, a RBE2, and grab the nodes on the curves of the hole for the dependent. And as the independent node, I'm just going to select one of the nodes on the vertical tube. And I'm going to repeat those steps for the other two tubes. So I have my model completely meshed now. I'm going to go ahead and set up my normal modes analysis. So I'm going to go ahead and create a constraint on the surfaces of the washers that I created earlier. It's going to prompt me to create a new constraint set. We'll call that anchor bolts. Again, I'm just going to go ahead and select the top surfaces of the washers and the inner ones. I'll continue on with this, but I'll skip ahead a little bit. So I'm going to highlight here. I have all my washers selected. And then I'm just going to use a pinned no translation constraint. So now I can go through the model info tree and just right click on analysis and hit manage. And I'm just going to create a normal modes analysis. Again, because my constraint set is active, it automatically grabs that. I can kick this off and fairly quickly I have my results read in. So I'm going to run through the mode shapes real quick. I'm going to turn on my contours. We'll turn off the geometry. I'm going to zoom out a bit, and you can see all the symbols from the rigid elements. So I'm going to go ahead into view options and turn those off. So the hotkey is F6. And then I'm going to go into element rigid and turn off draw symbols. And now I can show the animation of the different mode shapes. Thank you for watching this video on how to set up a radio tower model in Femap. I hope you found it insightful, and if you have any questions, please direct them to the Femap community forum with the link provided here.